The next question they will ask us from the same concept. Plot graph between I will ask plot graph for kinetic energy, potential energy, and total energy as a function of x. They will not mention x, it can be displacement, it can be y also. Okay, but the logic is the same. Now see. Kinetic energy, potential energy, and total energy, everything will be on the y-axis, and displacement will be on the x-axis. Okay, because the kinetic energy, potential energy, and total energy, they are considered to be dependent on displacement, not the vice versa. So we know that y is dependent axis, x is independent axis. So what is the expression for kinetic energy that we obtained in this case? It was half m omega square into a square minus x square. Okay. What is the expression for potential energy that we have obtained? It is half m omega square x square. Right? Potential energy is, where is it? It is half m omega square x square. Now observe, if I write potential energy is equal to some constant time x square, potential energy is on y-axis k into x square. Okay. Y is equal to kx square. What shape does it represent? Recollect it from your conic sections. Or see, if you don't know conic sections, you can recollect it from last year's math also. In your 10th standard, you would have learned. A second degree equation in one variable, what does it represent?
Sir, say the question again, sir.
Second degree equation in one variable. That is a quadratic equation. What shape does a quadratic equation represent?
Parabola, sir.
It's an upward parabola. Right. So y is equal to kx square represents an upward parabola. So this is the graph for potential energy. Okay. If you take kinetic energy, then kinetic energy, I've already written the expression half m into omega square into a square minus x square. So this is also a quadratic equation, but the coefficient of x square is negative. Observe, no? If I expand and write kinetic energy, it is half m omega square a square minus half m omega square x square. If you observe, this is also kinetic energy is also a second degree equation where this is a constant and this is a variable. Where coefficient of x square is negative, this also you would have learned. When the coefficient of x square is negative in the case of a quadratic equation, what does it represent? It's a parabola only, but a downward parabola. Are you guys able to understand this? Right. Now, what can you say about the total energy? Total energy is half m omega square a square. Is it dependent on x? Is it dependent on x?
No, sir.
It is independent of x, right? So where will this value of half m omega square a square exist? Observe, no? Kinetic energy is equal to this value, no? Tell me, at x is equal to 0, what is going to be the kinetic energy? Half m omega square a square, which is nothing but this value. I'm putting a dot here. So this value is half m omega square a square. And what is the value of total energy? That is also half m omega square a square, which is a constant value. So how is the graph for constant? Y is equal to constant. How does it look? It is a straight line parallel to x-axis. So that I will draw it with dotted lines. So this is the graph for total energy. And this red color one is for the potential energy. And the black color one is for the kinetic energy. This graph is also a must. They will definitely ask this. Or else they will ask it in a different way. They'll give you the graph and ask you to plot what they are. Upward parabola is potential energy. So you can remember it like this. Potential energy, the symbol used is U. Right? U is like an upward parabola only. So upward parabola is potential energy. Down. So obviously you will get the remaining two. Downward will be kinetic. The one which is constant is total energy. So there is a particular displacement, right? There is a particular value of x for which potential energy and kinetic energy are meeting. The graph of the potential energy and kinetic energy are meeting. So what will that point represent? So the point where the potential energy and kinetic energy are meeting, can I say that they both are having the same magnitude?
Yes, sir.
So if I take this point as P, okay, I don't want to use P. Let's say A and this point as A dash. Can I say at A and A dash, potential energy is equal to kinetic energy? Right? If that is the case, then what is the value of potential energy? Half m omega square x square will be equal to kinetic energy. Half m omega square a square minus half m omega square x square. Are you able to understand this? I just wrote these values. Half m omega square a square minus half m omega square x square is the expression for kinetic energy. Left hand side is the expression for potential energy. So what I can do is I'll bring this term to the other side. So half m omega square x square plus half m omega square x square is m omega square x square is equal to half m omega square a square. Cancel. So x square is equal to a square by 2, which implies x is equal to plus or minus a divided by root 2. So this can be a 1 mark question. For a particle in SHM, they can put a question like this. For a particle in SHM, what is the displacement from the mean position? I'm repeating it. What is the displacement from the mean position at which the potential energy is equal to kinetic energy? What will be your answer? It is plus or minus a by root 2. And commonly made mistake is most of them write it as a by 2, which is exactly half of the amplitude. That is wrong. You don't make that mistake. Have this point in your mind. It is plus or minus a divided by root 2. If you want to copy something, let me know from where I should show.
So here x is displacement, right, sir?
X is the displacement from the mean position. Please make a note of
Okay,
it.
sir.
Okay. So plus or minus a by root 2 is the answer. Let me show you where it is in the textbook also. So energy in SHM, it's all this derivation, and this is the graph. Okay. The upward one is u of x, downward one is k of x, and the line which is parallel is, total energy. Okay.